Let's take a look at how 3 data professionals use 3 different tools to deal with a column of nested data, and then we'll see how AI handles the task. For this data drill, the objective is to flatten a column of nested JSON data by unpacking its items into individual rows in a table. For example, we want to turn this order record with 2 nested line items into these 2 separate records, 1 per line item. And we'll want this solution to apply across all orders, no matter how many items they have. So let's download the dataset and get to work. Let's start with the Power Query solution. Now, I'm using Excel here, but we can apply the same solution in Power BI as well. So let's connect to our CSV file. I'm going to go to Data, then Get from Text CSV. We've got our sales order CSV file that we can connect to. Let's import that. Wait for that to load. And what we want to do is transform this data inside of Power Query. So let's do that. Going to have the Power Query window pop up, and this is where it's exactly the same in Excel as in Power BI. Now you'll see that we've got our order number, our order date, and then we've got this nested line items column. So if I click on any one of these records, you'll see that, for example, for order 387005, it looks like we have 3 different line items. So the first one, if we look inside the first level, you'll see that we've got product information and we've got the quantity for that product, in this case being 3. And if we look inside this nested JSON here, you'll see that for the product, we also have the product name and the product price. And the same applies for the other 2 line items. If we take a look at our next order, click on that, you'll see that we only have 2 line items for that. We've got 1 for the third one, and we've got 3, 4, it looks like 4 line items for the 4th order, and so on and so forth for the rest of these. So what we want to do is unpack these and create a product name column, a product price column, and a quantity column, and have each of these values populate as new rows for each order number. So to do that, all I need to do is go to Transform, and we want to parse through this text column, which we know is formatted as a JSON. So as we do that, you'll see that it converted the JSON into these list objects. And if I click on the cell now, you'll see that we have 3 list records, 1 for each line item. So 3 in the first order, 2 in the second, 1 in the third, and 4 in the fourth. So now all we need to do is expand each of these records into new rows. As I do that, we'll see that now for the first order, which is 387005, you'll see that we have these 3 records here. And if we want to look at the data underneath, you'll see that we've got the product, which again is another nested record, and the quantity. Again, all we need to do is extract those values. We don't need the original column name as prefix. Press OK. We have the quantity now, and all we need to do is unpack this nested JSON inside the product. So again, let's extract the product name and price. Again, we don't need the prefix. Press OK. Now for this first order, 387005, we've got these 3 products, price for each one, the quantity for each one. So we can maybe change the data type on each of these. This is text. This is currency. And this is a whole number. And now what we can do, home, we can go to close and load to. In this case, we can import it directly as a table to our spreadsheet. Do it to the existing one. Press OK. And we get our sales data in a proper tabular format that we can now analyze. And that's how I'd flatten the stack using Power Query in either Excel or Power BI.
To tackle the problem using SQL, I've opened up my SQL Workbench and loaded the data into the orders table. So if we take a look at the orders here, you can see we have the order number, order date, fulfillment, and then this really messy line item column. And these are the values that we want to extract. So to answer our question, what is the sum of total online sales? The first thing we're going to do is extract the JSON elements. And we're first going to do this for a single JSON array so you understand the high-level concepts before we apply this to this entire column of data. So for now, I'm just going to paste this value up here, and you can see here that I have the square bracket, and then within there, I have 3 dictionaries, and that's what's in those curly brackets. So what we're going to do for this first step is extract those 3 items and those curly braces into 3 different rows, because currently everything is 1 row here. So to do that, I'm going to do a select all from, and then I'm going to specify a JSON table, and that's going to help me turn these items here into different rows. So first I'm inputting in the string, and then I have to specify what part I'm looking at. So in this case, we're going to start from the very top, and I want to extract all the items. And I also have to specify the name of the column I want these to go into. So I'm going to type columns, and I'm going to create a new column called element. And I'm going to specify that the type of that column is a JSON data type, which is this structure that you see here. And then what do I want to populate that column with? I'm going to say everything. So now I can close all my parentheses and save this JSON table as a line item. Now, if I run that, you can see what we've done is we've turned this single string here into 3 rows. And these 3 rows represent these 3 dictionaries. So now that we have these 3 rows, now let's extract the different key value pairs. So we're going to extract the product name, price, and quantity. And to do that, I'm going to copy this entire query up here, down here. And instead of just saying, I want to see everything, I'm first going to specify that element, which is this column right here that we currently see. And now I'm going to extract this product name. And I can do that using the JSON extract function. And in here, I'm going to say, take a look at the element, and let's start at the very top, and then go to the product. And from here, go to the product name. And if I do that, I can say as product name. Oops, I have an extra parentheses here. And if I run this, you can see the product name has been extracted from this. Now let's get rid of these quotes as well. I'm going to say JSON unquote. And if I run this, you can see we've extracted the product name. So let me do that with our other fields as well. Instead of just the product name, I also want the product price. And finally, I want the quantity. And now if I run this, let me also change these names here to price and quantity. So now we have the product name, product price, and quantity. And now that we've done that to a single JSON string, let's do it to our whole table. So for this, I am going to start with our orders table. And you can see we have a lot of line items here. And what we're going to do is for each line item, we are going to extract all the different dictionaries inside using that JSON table code we just wrote. And because I want to see this line item information next to that JSON data on the right, I'm going to join them together. And specifically, I'm going to do a cross join because that will return all the combinations. So for this line, it's going to be matched with 3 rows of JSON elements. So I'm going to name this orders table O, and then I'm going to do a cross join with this JSON table code we just wrote. So let me copy this whole thing down here. And instead of this string here that just has 1 string, instead we're going to put in this line items column. So I'm going to do O.line items. And now I can run this. And you can see for this order, it used to take just 1 row. Now there are 3 rows. And these 4 columns here are all the same. But then the one on the right here, each of these is a different element within that line item string over here. So now that we've done this, let's copy this down. And we're going to do the same thing as before. From this element column, we're going to extract the specific key value pairs. And we are going to use this code here to do that. So let me paste it down here. And now if I run this, you can see we get a ton of information. This was our original element. And now we have the product name, price, and quantity. And in addition, I am going to add back in some of those original columns from the orders table. So let me run this part right here. You can see we originally had order number, order date, and fulfillment. So I'm going to add that here. Order number, order date, and fulfillment. and we don't need this element anymore because we have all the clean extracted values. Okay, we have this really nice clean data set. So now let's copy this down to make our final calculations. We want to know what is the sum of total online sales. And so to do that, the first thing we're going to do is filter by online sales, and then we're going to multiply price by quantity and sum up all those values. So because this output looks so nice, I'm going to save it as a common table expression so that I can reference it as a table further down the line. So I'm going to say select all from CTE, and then I want to filter this just by fulfillment is online. And finally, I want to multiply the product price with the quantity, and I need to know the total sum of all that. And I'm going to save that as total. And if I run this, I get this as my total, and I also need to round this. And if I run that once more, the final total I get is 18,239. And that's how I'd flatten the stack using SQL.
To solve the problem using Python, I'll be working out of a Jupyter notebook. We're going to need two libraries to help do this in Python. Pandas, which is used for all things data, so we'll import pandas as PD. And there's also a very helpful library for working with JSON type data. And not surprisingly, that library is called JSON. With those two libraries, we'll be able to complete this problem. First, let's go ahead and read in our sales orders CSV file. So orders equals pd.read CSV sales orders.csv. And let's take a look at the head of this data frame. All right. And so we have order number, order date, and then we have this really nasty nested JSON object, and then we have fulfillment here. So the first thing that we're going to do is overwrite this line items column. We're going to apply a function called JSON loads. This is going to help get our data into a format that pandas can work with. So we'll do orders line items. And this is just going to be our line items column. And then we're going to apply the function JSON.loads. And if we take a look at the head of our data frame now, it really doesn't look too much different. So we still have this nested structure, but what it's gotten rid of is some of the line breaks and other junk that we don't need from that JSON file. And this is going to be much easier to work with. And so within each of these line items are multiple rows, one for each product on the given order. There is another very helpful pandas function that will explode out the elements of a list into separate rows. So we're going to use the explode method to give us a line for every line item in here. So we'll do orders equal orders.explode, and we'll pass in line items. Then let's take a look at the head of this data frame. Okay, and so now you'll notice that instead of having one row for every order number, we now have 3 rows for this first order because we've exploded out each of the lines and line items into its own row. We're getting very close to having what we want, but we still need to access the data within this product dictionary here. So we're going to create a data frame of just our line items. We have our general shape of our data frame correct. That is, we have the right number of row numbers, but we still need to access data within these line items. So let's go ahead and create a data frame called line items df. And this will be equal to, I'll break a line, pandas.json normalize. And we'll use orders line items. And we're going to pass a separator. This is just dictating how we want our columns to be named. So when we normalize a JSON row, what do we want to call this column? We're going to call it product_product name, and then we can rename it later. But let's go ahead and just take a look at this line items df now. And so we've normalized our line items dictionary here. Now we have a data frame that has quantity, we have the product name, and we have the product price. Just to make this a little bit cleaner, I'm going to rename our product column names. So we'll do rename product name. We're going to call this product name. And then for our product price, we're just going to get rid of that first product. So product price, we'll just call this product price. And then we're going to do this on axis equals 1. Okay, so we've successfully renamed our columns. And now what we need to do is concatenate these two data frames. So if we take a look, this first order number here, this first row corresponds with the first row here. The second row in this order, 387005, corresponds with the second row. So what we're going to do is basically mash these two tables together along their index or row number. So let's go ahead and do that now. So we'll store this in a data frame called result, and we're going to use pandas.concatenate or concat. And we're going to concatenate our original orders data frame, but we're going to drop the column line items since we have the line items we need already in this data frame up here. So we'll drop line items. The other thing that we're going to do is reset the index. This will allow us to concatenate along these indices without any issues. So our first data frame we're concatenating is orders, and then we need to concatenate that with our line items df. And usually we concatenate along axis 0, the rows, but this time we're basically merging these two together on their indices. So we're going to do axis equals 1. Let's take a look at the result here. And so there we go. We have for each order, every item within this order has its own row. We have the quantity, we have the price. All we need to do now is create a column that has the revenue for each item, and we will be very close to getting to our solution. So let's go ahead and do result. We'll call this rev for revenue. And this is going to be equal to result.product price times result.product quantity. And so we'll take another look at our data frame. Oh, and this is just quantity here. I used the wrong column name. And so we have our revenue per line item. Now we can go ahead and calculate the revenue of online items. There are a few ways to do this, but basically we can just sum this entire revenue column, although we need to filter to online first. But if we do result.rev.sum, this will give us a sum of revenue for all orders. And when I first completed this, I didn't realize it was only for online. So we have $201,000 in total revenue, but let's go ahead and query this down just to where the fulfillment equals online. So query, this will filter our table. And if we take a look, $18,239 is the revenue and the correct answer. So to recap, all we had to do was use a few functions to get our data into the correct format. First, we got this out of JSON format using JSON loads. We then exploded our line items so that our data frame had one row for each line. We then used JSON normalize to unpack this dictionary here and get us the item level information, including quantity and price. We joined that data back to our line item data, and we were able to get our revenue per row, which allowed us to calculate the total revenue for online orders. So we were able to successfully flatten the stack using just a few lines of code. And if we want to bundle all of our code up, we can see how compact this really looks. And this is the workflow we needed to get the revenue for our online orders. And that's how I'd flatten the stack using Python.
Finally, let's see if ChatGPT is up to the task. So I'm going to start by copying and pasting the objective here into a new prompt. Let's drop the CSV file into the conversation as well and maybe make some edits, flatten the line items, column with enough to JSON data, and then just say return the flattened CSV file that I can work with. See what we get. Looks like it's analyzing here, taking its time. And we don't really get to see its approach, but it looks like we do have 3 items for that first order number. We have a blank line item column, that's okay. But we do have the product name, product cost somehow, product price and quantity. I'm not sure where it got the product cost from, but let's see if we can download this and compare it to our Excel solution. Okay, so maybe let's just get the sum of quantity, 760, here in Excel, 760. So it looks like this worked properly. Interestingly enough, we don't get to see its approach, but that's how you can flatten the stack using AI. If you want to learn more from our instructors, well, you're in luck. Right now, you can get up to 50% off at Maven Analytics as part of our spring savings deal. Don't wait too long because this deal won't last. Now that we've completed this data drill, we can double check our solution by answering this validation question: what is the sum of total online sales? So if we go back to our Excel solution, let's create a sales column, and that's just going to be product price times quantity. And if we filter for online sales, and let's quickly get the sum here. It looks like it's 18,238.98. So let's go ahead and plug that in. You can round it up. Submit. And there we go. If you're interested in practicing your data skills with real-world cases, head to mavenanalytics.io and check out our data challenges. We launch a new one every other month, and we'll have data drills like these every month in between. Thank you so much for watching, and as always, make sure to like and subscribe for more data content just like this. I'll see you in the next one.